Hi everyone. Today we're going to study surface area and volume of a rectangular solid. By definition, a rectangular solid is a three-dimensional object with 6 sides, all of which are rectangles. This is a picture of a rectangular solid. The dimensions are length, denoted by L, width, denoted by W, and height, denoted by H. The formula for total surface area is here. That is 2 times the quantity LW plus LH plus HW. For the volume, the formula is length times width times height. Example 1. A plastic box 1.5 meters long, 1.25 meters wide, and 0.65 meter deep is to be made. It is to be open at the top. Ignoring the thickness of the plastic sheet, determine the first is the area of the sheet required for making the box. Second, the cost of sheet for it. If a sheet measuring 1 square meters costs 20 rupees. This is our figure. Let's begin with the first problem. The box must be open at the top. Thus, the total surface area formula will be like this. LW plus 2LH plus 2HW. Then we substitute the corresponding values. We have 1.5 times 1.25 plus 2 times 1.5 times 0.65 plus 2 times 0.65 times 1.25. The product here will be 1.875 plus the product here is 1.95 plus the product here will be 1.625 and the total will be 5.45. This is the total surface area. Then we write the unit of measurement as square meters. Let's write the answer opposite the first problem. Let's go to the second problem. What is the cost of sheet for it if a sheet measuring 1 square meter costs 20 rupees? So we will do this. Total area multiplied by the costs. So we have this 5.45 times 20. So we have 109 rupees. This is the answer for the second problem. Example 2. The floor of a rectangular hall has a perimeter 250 meters. If the cost of painting the 4 walls at the rate of 10 rupees per square meters is 15,000 rupees. Find the height of the hall. Note that the perimeter of rectangular floor is given as 250 meters. Remember the formula of perimeter. That is 2 times the quantity L plus W. Now, the area of the 4 walls. The formula is 2 times LH plus 2 times WH. Take note that we can rewrite this formula just like this. And that is 2 times the quantity L plus W times H. Now, this 2 times L plus W quantity is the same with our perimeter. We can substitute the value of perimeter for this portion. So we have 250 H. This is the area of the 4 walls. Since this is the area, we will write the unit of measurement as square meters. Now, the cost of painting per square meters of area is 10 rupees. So, the cost of painting the 250 each square meters area, and that will be 250 each times 10. We will get the rupees, and that is 2,500 each of rupees. This is equation 1. Now, given in the problem, the total cost of painting the walls, that is 15,000 rupees. And this is our equation 2. If we put together equations 1 and 2, we will have 2,500 h equals 15,000. From here we can get the value of h. Simply, we divide the equation by 2,500. So the value of h equals 6. And this 6 is in meters. So the height of the hall is 6 meters. Example 3. The paint in a certain container is sufficient to paint an area equal to 9.375 square meters. How many bricks of dimensions 22.5 centimeters times 10 centimeters by 7.5 centimeters can be painted out of this container? First, take note that the total area of one brick, we write our formula. And then, we substitute the values. So that will be 2 times the quantity, this group 22.5 times 10, plus this group 22.5 times 7.5, plus this group 10 times 7.5. We simplify the corresponding product. So we have here 225 plus 168.75 plus 75. The total of the numbers inside the grouping symbol is 468.75. Then we multiply this by 2. So we have 937.5. The area of measurement is square centimeters. Now, we let n equals the number of bricks that can be painted out by the paint of the container. So, the area of n bricks, that will be n times 937.5. In this case, we'll just put together this n and this number. It becomes like this. And the unit of measurement, we will just attach. Square centimeters. Let this be equation 1. Next, the area that can be painted by the paint of the container, this is given in the problem, 9.375 square meters. But in equation 1, this is in square centimeters. We're going to convert these square meters into square centimeters. Simply, let us multiply this by 10,000. So it becomes 93,750 square centimeters. This is our equation 2. If we equate equations 1 and 2, we will get 937.5 n equals 93,750. From here, we can now get the value of n. We divide the equation by 937.5. So n is 100. Therefore, 100 bricks can be painted out by the paint of the container. Today we're going to study surface area and volume of a right circular cylinder. This is a picture of a right circular cylinder. A right circular cylinder is a three-dimensional solid shape that consists of two parallel bases linked by a closed circular surface where each base is like a circular disc in shape. The line that passes through the center or joins the centers of two circular bases is known as the axis of the right cylinder. The distance between the two bases of the cylinder is referred to as perpendicular distance, which is represented as height, h. The distance from the center to the outer boundary for either of the two bases is known as the radius, r. Now, let's write the formula. First is the lateral or curved surface area. Formula is 2 times pi times radius times height. For the total surface area, that is 2 pi r times the quantity r plus h. What about the volume? This is equal to pi r square h. Example 1. The curved surface area of a right circular cylinder of height 14 centimeters is 88 square centimeters. Find the diameter of the base of the cylinder. Assume that pi equals 22/7. We have a formula about lateral or curved surface area that is equal to 2 pi r h. We can rewrite our formula with respect to diameter. We know that 2 times r is equal to diameter. So the new formula will be pi d h. D here is the diameter. Now let us substitute the corresponding values. The area is given as 88 square centimeters equals pi is 22/7. D we write here and that is what we want. H is the 14 centimeters. Now let us multiply this equation by 7 so that the denominator 7 goes to the left side. So we have 88 times 7 equals 22d times 14. Simplifying the products, the left side becomes 616 equals 22 times 14 is 308. Then we copy the d. We solve for d. We divide this equation by 308. So d is equal to 2. And the unit of measurement, centimeters. This is the answer. Example 2. It is required to make a closed cylindrical tank of height 1 meter and base diameter 140 centimeters from a metal sheet. How many square meters of the sheet are required for the tank? Assume that pi equals 22/7. This problem corresponds to the total surface area, and we have this formula. Given in the problem, first is the height, that is 1 meter. Second is the diameter, given as 140 centimeters. In the formula, we need the radius. So when we divide this by 2, the radius will be 70 centimeters. Another consideration here is we need the area in terms of meters or square meters. The radius is in centimeter. Let's convert this into meter. So it becomes 0.7 meter. Now let us substitute the values in our formula. So we have 2 times the pi 22/7 times r, that is 0.7, times the quantity, the sum 0.7 plus 1. Simplifying, 2 times 22/7 will give us 44 over 7. Then the sum becomes 1.7. Using our calculator, we will get the simplified value as 7.48. This is the area in square meters. Example 3. The diameter of a roller is 84 centimeters and its length is 120 centimeters. It takes 500 complete revolutions to move once over to level a playground. Find the area of the playground in square meters. Assume that pi equals 22 over 7. Observe that the roller is cylindrical. Given in the problem is the length of the roller that is equal to the height of the cylinder, and the value is 120 centimeters. Also, diameter equals 84 centimeters. Now, let us compute for the curved surface area. Let us use the formula using diameter. So, this is pi d h. Substituting the values, we have pi as 22 over 7, d is 84 centimeters, h is 120 centimeters. The answer here is 31,680 square centimeters. Let us find now the area of the field. So, 500 times the CSA or the curved surface area of the roller. The value is here. So we have 500 times 31,680 square centimeters. This is 15,840,000 square centimeters. Observing our problem, we need the area in terms of square meters. The value here is in terms of square centimeters. To do that, we just divide this value by 10,000. So we have now 1,584 square meters. This is the answer. Today we're going to study surface area and volume of a cone. This is a picture of a cone. In particular, this is a right circular cone. In this video, we're going to study the surface area and volume of a right circular cone. Let's go to some definitions. A cone is a shape formed by using a set of line segments, or the lines which connects a common point called the apex or vertex to all the points of a circular base, which does not contain the apex. The distance from the vertex of the cone to the base is the height h of the cone. The circular base has measured value of radius r, and the length of the cone from apex to any point on the circumference of the base is the slant height, capital L. Now let's go to formulas. First, curved surface area of a cone, and that will be pi r L. For the total surface area, that is equal to pi times r times the quantity r plus L. And the volume equals 1/3 times pi r square times h. Example 1. The diameter of the base of a cone is 10.5 centimeters and its slant height is 10 centimeters. Find its curved surface area. Assume pi equals 22/7. The formula for the curved surface area is here. Now, let us write the given starting with diameter, that is 10.5. In the formula, we need the radius, so we divide this by 2. Thus, radius equals 5.25 centimeters. Another given is the slant height equals 10 centimeters. Now let us substitute the values to our formula. So we have pi as 22/7 times 5.25 times 10. And the final answer is 165 square centimeters. This is the curved surface area. Example 2. Find the total surface area of a cone if its slant height is 21 meters and diameter of its base is 24 meters. Assume pi equals 22/7. The formula for the total surface area is here. Let us write the given starting with diameter equals 24 meters. In our formula, we need a radius. So we divide this by 2, thus the radius equals 12 meters. Another given is the slant height, that is 21 meters. Now let us substitute the values to our formula. So it becomes 22/7, that is the pi, times radius, which is 12, times the quantity of the sum, r plus l. So we write here 12 plus 21. We multiply 22 by 12, that will be 264, and this 33. We just copy this denominator here. Then the final answer is 1,244.57 square meters. Example 3. Curved surface area of a cone is 308 square centimeters and its slant height is 14 centimeters. Find, number 1, radius of the base. Second, the total surface area of the cone. Let's begin with the first problem. Let us write the formula for the curved surface area, and it is here. Then let us substitute the corresponding values. The curved surface area is given as 308 equals pi is 22/7, r is the radius, and that is our requirement, and capital L is the slant height, which is 14. We simplify this equation by removing the denominator. We multiply this equation by this denominator 7. So 7 comes to the left side. Let us now simplify the corresponding products. On the left, we have 2,156 equals the right side 308r. Solving for r, we divide the equation by 308. So r equals 7 centimeters. Let's copy this answer opposite problem 1. We proceed to problem 2, total surface area. We write the formula for the total surface area. Then let us substitute the corresponding values. Pi is 22/7. Radius we derived as 7 times the quantity r plus l. So that is 7 plus 14. In here, we can see that we can cancel the denominator and the 7 here. Then we add 7 plus 14 as 21. The product now is 462 square centimeters. We write this answer down of the second problem. We have now the final answers. Example 4. The height of a cone is 15 centimeters. If its volume is 1,570 cubic centimeters, find the diameter of its base. Use pi equals 3.14. We write the formula for the volume, then we substitute corresponding values. Given the volume as 1,570 equals 1/3 of pi, we write 3.14. We can get here the r square, then later we will get the radius. So we copy here r square, and the h or the height of the cone is 15 centimeters. On the right side, we can simplify the numbers. 1/3 of 15 is 5. 5 times 3.14, we will get 15.7, and this is r square. We divide this equation by 15.7 to get r square. So r square equals 100. We need the r or the radius. Simply, we take the square root of both sides. Therefore, r equals 10 centimeters. In the problem, we need the diameter. So we multiply this by 2. Therefore, diameter equals 20 centimeters. Today we're going to study surface area and volume of a sphere. This is a picture of a sphere. A sphere is a geometrical figure that is round in shape. The distance between surface and center of the sphere is called its radius, r. The distance from one point to another point on the surface of the sphere, passing through the center, is called its diameter. The region occupied by the surface of the sphere is called its surface area. The amount of space occupied by any spherical object is called its volume. Now let us write the formulas. Starting with the surface area, or SA, and that is equal to 4 times pi times square of radius. And the volume V equals 4/3 times pi times the cube of the radius. Example 1. Find the volume of a sphere whose radius is 7 centimeters. Assume pi equals 22/7. We write the volume formula, then we substitute the corresponding values. 4/3 times pi, we write 22/7 for the pi, and r cube is 7 cube. We can multiply the two fractions. 4 times 22 is 88, 3 times 7 is 21, and the cube of 7 is 343. Using the calculator, we can get the final answer as 1,437.33 cubic centimeters. This is the volume. Example 2. The diameter of the moon is approximately 1/4 of the diameter of the earth. What fraction of the volume of the earth is the volume of the moon? First, let us assign d equals diameter of the earth. Therefore, the radius of the earth, simply we divide diameter by 2. So we write here d/2. In the problem, diameter of the moon is approximately 1/4 of the diameter of the earth. That means d/4 equals diameter of the moon. If we divide this by 2, we will get the radius of the moon. So, radius of the moon equals d over 8. Now let us write the volume formula. With regard to the fraction, we can write volume of the moon over volume of the earth. Let us now write the formula for the volume of the moon over the volume of the earth with respect to their corresponding radius. So the volume of the moon, we have here 4 over 3 pi times the cube of d over 8 all over volume of the earth. So we write 4 over 3 pi times the cube of the quantity d over 2. Then let us simplify. Notice that the values 4 over 3 pi is common to the numerator and denominator, so we can cancel them. Then let us simplify the remaining values. D over 8 cube, it becomes d cube over 512 all over the cube of d over 2, it becomes d cube over 8. Let us rewrite our complex fraction here as d cube over 512 times 8 over d cube. We can cancel the d cube. Then we simplify the fractions. 8 over 512 is equal to 1 over 64. We simply divide the numbers 8 and 512 by 8. So we reach this simplified fraction. Then we say that the moon's volume is approximately 1 over 64 of Earth's volume. Example 3. Find the volume of the sphere whose surface area is 154 square centimeters. Assume pi equals 22 over 7. We write the surface area formula, 4 times pi times r square. Then let us substitute the corresponding values. SA, the surface area, is given as 154 equals, we copy the number 4, the pi becomes 22 over 7, then r square, we simply copy down here. In this equation, r is the only variable, so we can solve for that. First, we can simplify this fraction. Let us multiply the equation by this denominator, that's 7. So the number 7 comes to the left side. So it becomes like this. 154 times 7 equals 4 times 22 r square. Let us simplify the corresponding products. On the left side, we have 1078 equals 88 r square. We want r square here. So let's divide the equation by 88. The r square now equals 12.25. We take the square root of both sides, so we will get the value of r, or the radius, as 3.5. Then, let us write the volume formula. Let us substitute the value of the radius as we derived here. So we have 4 over 3 times the pi, 22 over 7, times the cube of the radius, 3.5. Simplifying the fractions, 4 times 22 is 88 over 3 times 7, 21, times the cube of 3.5, that is 42.875. Using the calculator, we can get our final answer. We multiply 88 by 42.875, then divide by 21. That is 179.67 cubic centimeters.